Greetings and welcome to another installment of Quantities. This is 8 in our basic application series. This time around part 2 in our mini-series on continuous quantities. As we saw in part 1 that we just concluded, continuous distributions arise when the domain of values for a quantitative variable or attribute is continuous, like a tabletop. In most settings, a continuous quantity will have an infinite domain. Now, we've already encountered infinity here on Quantities, going all the way back to the foundational series. We considered imaginary populations with an infinite number of elements, and we survived that okay, I think. However, to fully harness the power of continuous distributions, we not only re-encounter infinity, but we need to manage it. Fortunately, the good news is that the theory of managing infinity in this way has already been taken care of for us. To enrich our understanding of what all this means, for this edition, we are going to embark on a veritable Homeric odyssey of some properties of numbers. Slight exaggeration. We're going to start with the set of integers. The set of all integers is typically represented by capital Z here. Usually, notationally, we use blackboard bold typeface. It's not mandatory, but it's very typical. The Z comes from the German word Zahlen, which is plural for Zahl, which means number, or probably a better translation is numeral. This is, I think, a pretty easy set to think about. It's basically all the whole numbers along with all the negative whole numbers, or if you like fancy math talk, the set of integers is the union, meaning to bring everything together, of all the whole numbers and their additive inverses, so-called. -3 is simply the additive inverse of 3. Now, the set of rational numbers here is typically represented by capital Q, again, usually in blackboard bold typeface. The Q comes from quoziente, meaning quotient, so named by the Italian mathematician Giuseppe Peano. This was maybe about a century ago, a little bit over. The set of rational numbers is made up of all the numbers that can be expressed as a ratio of integers. We exclude, however, division by 0, so the b here, the denominator, cannot be 0. To give us one perspective on infinity using the rational numbers, we're going to consider a property known as denseness. Imagine that someone is allowed to pick any two unequal rational numbers. Our job will be to find another rational number that sits between the two numbers. So just for an example, say someone chooses 1/4 and 1/2. Both are rational numbers, they're different, unequal, so we'll choose, say, 2/5. 2/5 is greater than 1/4 and less than 1/2. One more. Someone chooses 1/1000 and 2/1000. Again, they're both unique rational numbers, and so we'll choose, say, 3/2000. And you can see where we're headed here. The set of rational numbers possesses this fascinating property that for any two different members, we can always find another member that sits between them, meaning that it's greater than one of them and less than the other. Notice, by the way, that the set of integers does not possess this quality. So, for example, if someone chooses the elements, say, 1 and 2, there is no integer that resides between them that is greater than 1 and less than 2. So the set of integers is not dense. Okay, back to the rational numbers here. The set of rational numbers, I think, offers a really fascinating window into infinity. Consider just the subset of rational numbers between, say, 0 and 1. This subset itself is dense, just like the larger set of all rational numbers. It therefore contains an infinite number of values. And I don't know, to me this is sort of amazing. There are an infinite number of ratios of integers in the unit interval, that is, between 0 and 1 inclusively. If it should please you, it would please me greatly. Subscribe to this channel. Make sure to check out part 3 of this mini-series upcoming. That's it. That's going to do it this time around. Thank you so very much for tuning in. Really do appreciate it. And don't forget to stay tuned for more Quantities.